So with number one, we're given two functions we're trying to find. Actually, these aren't functions. I should take my words back there. These are not functions. They don't pass the vertical line test. What are these graphs going to look like? Anybody know just by looking at the equations? Sideways parabolas, right? So they're not actually going to be functions, they're relations, but we have these two equations that represent two graphs. Now, in order to graph them, we're going to use our calculator to help us, and we need to solve these for y. So we want this to be y equals, but this is only for the graphing purposes. The rest of this, setting up the integral, we're actually going to have to solve for x. But for the graph part, we need to, no. Alright, so for the graph, alright, let's try this again. So, for this, in order to look at the graph, we need to have it as y equals. Right? So just for the graphing purposes, it has to be y equals. Then we have to determine if it's going to be a dy cut or a dx cut. And that helps us figure out, is it solving for x or solving for y? But to start off, we need to graph it. We have to have it as y equals. So for this one, we're going to divide both sides by 2. Y squared equals 1/2 x plus 2. And then we take the square root, we get y equals positive or negative square root of 1/2 x plus 2. So very important to have the positive or negative. Really, it's kind of like two different functions together that make this equation. And then for this one, we get y equals positive or negative square root of x. So let's take a look at these graphs. So we're going to have positive square root of x, negative square root of x. We're going to have positive square root of 0.5x plus 2, and negative square root of 0.5x plus 2. So that first one is our positive and negative square root of x. This graph here is going to be the positive or negative square root of 1/2 x plus 2. Alright, so on here, we can kind of sketch a graph. It doesn't have to be perfectly to scale by any means. But we have this graph and this graph. Now, we're going to have to determine, is it a dx cut or a dy cut? Meaning, do we have one function that's above the other one the whole time, or do we have one function that's to the right of the other one the whole time? Well, it's going to be kind of easy today because they're all going to be to the right of the other one, but eventually you're going to have to make that decision. But let's look at this one, why we can't do a dx cut. If we look at this like vertically, like we're looking to see if one graph is above the other one. To start off with, the red graph's above the blue one for a while, but then when we get over here, the red one's above itself. And down here, the blue one's above the red one. So that makes it very complicated if we were to try and use vertical rectangles to find the area, or to use a dx cut. But if we look at this horizontally, the blue one, if we do like horizontal lines, it's almost like a horizontal line test, then if we draw horizontal lines, it goes to the blue one first, then the red one, blue one, then the red one. Every time we draw a horizontal line, like from right to left. So that means we can use a dy cut. Right? We could use like a horizontal rectangle. We're going to use a dy cut, which means everything in our integral is going to be in terms of y. And remember, that means we're going to take the right function minus the left function. So which one's the right one? The blue or the red? The blue one, right? This is going to be our right function. This one's going to be our left function. Now, in order to do this, everything has to be in terms of y, which means solved for x. So like this one's already good to go. We have x equals y squared, right? That's our right function. This one we have to solve for x. X equals 2y squared minus 4. That's our left function. So when setting up our integral, it's just the right function, y squared, minus the left function, we're going to put that in parentheses, 2y squared minus 4. And then that's dy in terms of y. Right, so this y squared minus 2y squared minus 4, that gives us like kind of, in this, if we're looking at it this way, kind of the base of the rectangle. The height of the rectangle would be dy, base times height. Well, we have to find these two values. Those have to be in terms of y also. So we would need the lowest y value and the biggest y value. So the lowest one's going to be down here. Again, our graph's not really perfect. All right, we didn't draw it to scale. So we're going to have a y value down here and then a y value up here. We can do that and find that the same way we did with x's. We need to set these equal to each other. So we want to know, when is y squared equal to 2y squared minus 4? So if we subtract y squared from both sides, we get y squared minus 4. So 0 equals y plus 2 or y minus 2. So we get y equals negative 2, y equals positive 2. So this value down here should be negative 2. Value up top should be positive 2. We can simplify, I mean, you can leave this as it is, and a lot of times on AP tests or even like on our quizzes and tests, sometimes I'll just say, set up the integral. You don't have to like put it in your calculator and solve. You can leave it like this. If you want to, if you're going to put it into your calculator, I would suggest just kind of simplifying the inside so you have fewer parentheses. Just distribute that. Y squared minus 2y squared gives us negative y squared, and then minus negative 4 gives us plus 4. So this we can put into our calculator. So math 9, negative, we can put it in terms of x, that doesn't change things. Negative x squared plus 4, comma x, comma negative 2, comma 2. So we should get 10.6 repeating, and we can change that to fraction. We have 32 thirds.